Oh, hello. Welcome. Is my camera just gonna fight me today? Oh no, I think we're gonna be okay. Welcome. My name is Will, and I'm super psyched to be here with you on this lovely Global Hack Week. We are gonna hang out for just a second while folks kind of pull in, and we will just chill until we kick things off. Maybe like in 3 minutes. But jump into the comments and let me know how it's going. Oh my goodness, I see some familiar handles. Stuart, I definitely remember you. That sounded kind of ominous. That was like, oh, I remember you. To be clear, it wasn't. It's good to see you. But yeah, welcome. We're kicking off the machine learning track, and I am just super thrilled to have you here. In the comments, why don't you let me know where you're tuning in from, and let's see what the last beverage you had was. And for the sake of this question, smoothies do count as beverages because my last drink was a smoothie, and I had a smoothie. Also, drop in the comments. Actually, no, I'll only give you one thing to say. What's the last? Where are you calling in from, and what is the last beverage you had? And for me, that was a chocolate and banana smoothie that I just blended up. Welcome. Nyan, Amit, Fleabag, Misato, Stuart, Abigyan. Please let me know if I'm messing up your name. Just like drop in a little pronunciation tip in the comments, and I will try to be better. It does feel like my camera is going to fight me a little bit. I don't know what's going on. Maybe I'll zoom out a little bit. Maybe no. But welcome. Okay, thank you. I'm not sure how to pronounce that, but Afdinki for actually responding to the we have a couple answers. Let's see. Nyan said tea. Misato said agua de guava. That sounds tasty. Let's see. Canada, water. Very, very healthy of you, Stuart. Good for you. Gatorade. Love to see it. Cool. We will just wait another minute or two, and we'll do our little formal introduction. Oh, also, so if you have tuned into previous machine learning tracks for Global Hack Week, you may be familiar with the fact that I often will do some kind of, it's not really a competition, but kind of fun game where you all get to vote on something that I will then do or something, right? So last time you got to pick what color I dyed my hair, and you picked blue, and so my hair was blue for a couple of days. Before that, named my fish, which I actually have bad news. 2 of them passed away, but 3 of them are still there, and the snail Harold is still kicking. And so I'm thinking about it, but I think actually this, because I don't want to just do the hair again. This time, if every time you attend a session, you will be able to cast a vote for something that I will temporarily tattoo on myself. So this week we'll accept submissions of like a short phrase or word. I'm sure that somebody might want me to tattoo the name of a particular IKEA shark on my arm or whatever. But yeah, so stick around, play along with us, and pick what I tattoo on myself. Stay relentless. I love it. Yeah, it's pretty sad. But I think here's what I think happened with the aquarium. It's a relatively small aquarium, which I'll give you a zoomed in shot later. But I just think that the aquarium, because it's totally self-sustaining, there are a lot of plants growing in there, and I basically do nothing. I occasionally will put in some food, but mostly they eat the plants, and the bacteria processes the waste and everything. And I actually just think that we had 5 fish. I think it was above the carrying capacity of the aquarium. And that is why, unfortunately, 2 of the fish passed away. But we might add more fish. We might upgrade the aquarium. We'll see. Seek discomfort. I dig it. Okay, cool. We're 4 minutes past the hour. So maybe we dive in. Hey, Fleabag. Good to see you again as well. So yeah, we're going to dive in and get kicking. So this track, we're diving into machine learning. And tomorrow, we're going to talk a little bit more, not tomorrow, next session, on Monday, I believe. We're going to talk a little bit more about what machine learning is, and we're going to actually build a model that can look at a piece of art and figure out what artist created that work of art. Also, before I forget, I'm going to drop in the link that you should go to register for this event. So if you have not checked in yet, please go and check in. Be afraid and do it anyway. Wow, man, you're like really coming up with these tattoo little phrases. I dig it. Also, please let me know if I am talking too fast in the comments. This is actually something that last session we did a lot of surveying, and most people felt like the speed of the machine learning track was okay, but it was a little bit on the fast side. So both like me speaking a little bit, but also just like how fast we cover content. And so this week, we're really just going to have a fun time, and we're not going to try to cover like a whole bunch. We will have a working machine learning model by the end, but if it feels like the pace might be a little bit slower than times previous, that is intentional. But I will also send out a little poll at the end, actually throughout, that you can fill out and basically tell me like, are we going too fast? Are we going too slow? And I'll try to adjust accordingly. But yeah, so we're doing machine learning, and I'm going to, over the course of this week, I'm gonna get a temporary tattoo, and you're gonna help me pick out what it says. So the first day, today, you're gonna get to submit a phrase, and then on subsequent days, we'll like vote on what phrases we like. And today we're just gonna do a little gentle introduction to Python. So if you already know Python, a lot of this is going to be review, but I would say please stick around. We're just going to chill and have a good time. Also before I forget, one of my other big things for Global Hack Week is, is it here? No, it's over there. Whew. Got to wear my flower crown. It's pretty important. Whew. Okay, I'm super glad to hear that the speed of my voice is not too bad. But yeah, if you're familiar with Python, you could link up with us in the next session and you'd be okay. But I would say stick around and hang out. And maybe we will cover something that you have not seen before. Sweet. So I guess I'll do the formal, like, I'm a person, here's my introduction now that we're actually starting. Oh, hello. Maybe. This is also just the time of the month where I just get to fight with my computer a lot. Okay, come on. Come on, friend. Enter full screen. Just really does not want to go into full screen for me. Well, hey, my name is Will. I am a software engineer at Google. That's my kind of full-time work. Part-time, I am a coach at Major League Hacking, where I do things like this. I am a Python enthusiast, an active mountaineer. I just climbed Mount St. Helens 2 days ago. And I am really, really excited to be here. I'm really excited to chat about Python and machine learning. I think it is super fun stuff. And I'm glad you're here. As I previously mentioned, let me know in the comments if you ever have any questions, and hopefully I will check in with that and answer anything that comes up. But so today we're just going to jump right into our introduction to Python, and that is going to begin with learning about a tool called Colab, which many of you are probably already familiar with Colab, but we will jump into it for those folks who are not familiar. Oh, sweet. Okay. Now, this is probably going to be a little bit small for folks, so maybe we will just zoom in a little bit. Oh, come on. Okay, let me know if this is visible or if I need to zoom in more. I know some folks are like tuning in from smaller devices, maybe an iPad or a phone. And so we are going to just go to this URL, colab.research.google.com. And I will plop that into the chat so you can join along with us. And this is just an easy way that we can all work basically in the same environment, right? So if you run a line of code and I run the same line of code, we should get the exact same results. If you were running it on your computer locally and I was running it on mine, we might have different operating systems and different versions of Python, and it would just be a mess. So Colab kind of lets us all see the same thing at the same time. Additionally, it is a really nice way to play around and experiment. And if you get into sort of the machine learning space, you will see a lot of machine learning scientists using really the actual technology is called Jupyter Notebook, but it is a way of writing a little piece of code and running it and seeing what happens. So I guess without further ado, we will jump into Intro to Python for Machine Learning. And so we're just going to learn some kind of all the basics. And afterwards, I will publish this code on GitHub and share that link in Discord. So if you want to follow along in real time, that is awesome. And you can also see what we did later. OK, so Python is a programming language. It lets us tell the computer what we want it to do. And kind of the most basic thing we're going to ask the computer to do is to remember something for us. When we ask a computer to remember a piece of data, it's called creating a variable and storing data or assigning a value to a variable. If you want to, so someone asked it, can we just use Jupyter? And you are more than welcome to. What I will say is that later when we get into certain things, like when we start using TensorFlow and some of these other libraries, Colab is really nice because it has all of the stuff already installed. So if you use Jupyter, you are going to have to figure out your own dependencies. And if you ask a question about dependencies, I probably won't be able to make the time to help you. But if you're like, hey, I know what I'm doing, then yeah, feel more than welcome to use Jupyter locally. Cool. So if we want to make Python remember something for us, we declare a variable. And there are a couple of different types of data we can put in that variable. So the first type we'll look at is an integer, right? My integer will create a variable name into, can I spell integer? Cool. And we can use the equal sign to put something in our variable. So here I'll just put the number 6. And so this just tells Python, remember this integer. And if you remember from math, an integer is just a whole number. And it'll remember it as my integer. And so another thing that actually is fun about Colab is that whatever you put at the end of one of these little cells, it is going to basically print out for you. So if we run this by clicking this run button, we'll see we told it, remember my integer is 6. And it takes a second for the first thing you run. But then out here it says, oh, 6. That's what my integer is. So a few other just ground rules, ideas about Colab. We can get a new cell for a different piece of code. So we could do something like print hello, and we could run that. And that leaves this other cell kind of unaffected. So this is a nice way to write a little bit of code, test it out, and then write something else. You can come over here and delete a cell if you don't want it anymore. The other thing that it'll become more important later when we start running Python that takes a long time to run. But you can always come up here to the runtime and say interrupt execution. And this will basically stop the notebook from doing whatever it's doing and kind of let you fix things. And we'll look at using this a little bit later. But for now, you can type things in a cell. And you can press this little play button, or you can hit shift return, and that will run the cell for you as well. So hopefully everybody is in Colab and can actually write some code and run it at this point. So we'll throw in a few other data types in Python. So you can do what we call in Python a float, but the long form version is a floating point number. So I could say my floating point number and use that equal sign again, and type something that has a decimal point. So we could say 16.5, and this creates a float. So this is just like an integer, except it has some fractional part, right? And so down here, we could say my floating point number. And so if we run this code, it should print out both. Awesome, we get 6 and then 16.5. Python remembered it for us. Somebody asked if they can get a recording of the session, and yes, after this session finishes, it'll still be up on our Twitch And so you can rewatch it if you want. If now is not a good time, I understand. We're tuning in from all around the world, and my feelings will not be hurt if you watch later. Cool. So we have integers and we have floating point numbers. I'm going to throw another data type out there called a string. So I can say my string equals, and what I'll do here is I'll use these single quote marks and type hello. So in Python, a string is just a piece of text, and this text data is used quite frequently, and you have to remember to put those little quotes around it. Somebody asked, will we be working on Python basics for this entire session? And the answer is yes. So if you are like a Python pro or even Python intermediate, it might be pretty reviewy for you. And I would welcome you to hang out. I mean, we'll pick up some speed in a second here. But yeah, we're taking it nice and easy. And so if you already are pretty proficient in Python, you can jump in with us on Monday, and you should be able to do everything we're going to do. Cool. But yeah, stick around if you'd like. So before we print out, I'll do one more variable, and we'll say my Boolean. And a Boolean is just a computer sciencey word for true or false. And so we'll look at this later, where we have basically ideas that can be true or false, right? So like, I have blue hair is a statement that right now is false. But if you joined us a month ago at the last Global Hack Week, that statement would have been true. And this is kind of how we use Booleans. So I'll say my Boolean equals true. And it was true here, it doesn't have any quotes around it. So hopefully most of this should, if you've learned any programming language, most of this should feel pretty familiar. So we can just run all of these, and we get our data types, our variables, just like we asked Python for. Cool. Let me know how the speed is going, but I'm going to pick up the pace just a little bit because my sense is for a lot of folks this really is review. But if anything doesn't make sense, drop a question in the chat, and I will monitor it very closely. All right, so now that we have some data, we want to be able to do stuff with it. Oh, Yadav said they're late to the party, and no worries, you are actually not that late. You missed some of the setup, but if you want to join us over at collab.research.google.com, you can join right along. We're just doing some intro to Python. And welcome to the party. It's good to have you here. Okay, so now we have some data. We want to start doing stuff with it. And the most basic thing we'll learn how to do stuff with is basically doing arithmetic with numbers. So I'll start out with two numbers. Let's say A equals 25 and B equals 5. So now I will say maybe A plus B. And we'll just set that to A plus B. So what's going on here is I am adding these two variables. I'm telling Python whatever A is and whatever B is, add them together and put them inside a new variable called A plus B. And so we could come down here and we could print out A plus B, right? And we get 30, which makes sense because 25 plus 5 is 30. All right, I'm going to jump in and do three more arithmetic things, and then we'll print them all out and see that it does what we want it to do. So we can say A minus B, and that's going to be just A minus B. Pretty straightforward. We'll do A times B. You'll also notice that Colab tries to be helpful and will give you these little pop-ups, but sometimes they can be annoying. And I think you actually can turn them off, which maybe we'll discover how to do in a later session. But if you keep typing, they will disappear. So A times B, here we just use the star symbol or like the asterisk. So we don't use like an X because X is just a letter that we could use in a variable name. So we just use the star. And then finally, we'll say A divided by B. And we'll say A is divided by B. Now, one quick note is that this is a / for dividing. Depending on what version of Python you're doing, it might just be an error, but this / is not how we're going to do sort of basic division. And so then we will just print out all of our values just to make sure that they look like what we think they should look like. And great, so A plus B is 30, A minus B is 20, that makes sense, 25 minus 5 is 20, A times B is 125, the math nerds out there will confirm this is true. And then A divided by B is 5. Now, one fun note here is that even though A and B started off as integers, When you do division, even if it's a whole number, you will get a float back. Because when you divide two things, you could get some kind of fractional part. And so Python basically says, hey, I know we're doing division, and so I'm not going to pretend to give you an integer back. I'm going to give you a floating point number. So if there is a decimal point, then you'll get the right answer. So cool, we can do arithmetic. You can also group things in parentheses. So I'll say calculation 1, and we'll set that equal to parentheses 12 minus 6, and then all of that minus 2. Sorry, divided by 2. So 12 minus 6 is what we do first, so that's 6, and divided by 2, that's 3, right? But then for calculation 2, oh, I can't spell calculation. Calculation 2, and we will set that equal to 12 minus parentheses 6 divided by 2. Basically the answer here is that it works the same way as math usually does. So we can get out calculation 1. Hello, Gunit. Welcome. Calculation 1 and calculation. And in this case, you can just arrow down and hit tab to autocomplete for you. And cool. So hopefully this is not a surprise. The parentheses tell you do this part first. So in this case, we're doing 12 minus 6 first and getting 6 and dividing 6 by 2, which is 3. And that gives us 3. And in this second example, we're first doing 6 divided by 2, which is 3, and then subtracting that from 12, which gives us 9. If there are any questions about that, you can drop them in the chat, but we're still just kind of doing math, so hopefully that feels okay. Another fun tool in Python is what's called the, well, I actually don't know what it's called. I would call it the plus equals operator, but basically this allows you to do an operation and store it in the same variable. And I'll show you what that looks like. So say we have a variable that's called day of the month. And we set it equal to, oh, it's the 10th, right? But if I want to increment that by 1, so if I want to say, oh, it's the next day, I can say day of the month. And one way I could do this is I could actually grab that variable and say +1, and then store all of this back in day of the month. So what we're doing here is we're saying Python, whatever's inside day of the month, which is 10, get that, add 1 to it, and then put it back inside day of the month. And so we'd end up with 11 down here. And this is fine. There's nothing wrong with this. But something that is fun is instead of all of this, we can just say days of the month plus equals 1, which basically just says add 1 to that variable and keep it in that variable. And so if we run this, we still get 11. So this is a nice little sort of shortened syntax you can use. You can, of course, also do things like multiply it. Not that we would multiply days of the month, but this would give us 20. And subtract and divide work the same. Awesome. So that's our look at numbers for the time being. And now we're going to dive into strings. So there are lots of cool things we can do with strings as well. Let's say my name is equal to Will. Oh, also a note. I used single quotes at the beginning, and now I'm using double quotes. You can use either. The single quote here and the double quote work the same. Usually what we say in Python is you should just pick one and stick with it. And I'll say, actually, at Google, we have a standard of using the single quote just because it's simple. I don't know. But yeah, feel free to use either. Let's see. Python operators don't follow math bombus rule. Okay, I'm going to assume that bombus is another version of PEMDAS, which is what I learned. And the answer is no. Yeah, Python will not do PEMDAS automatically for you. In fact, we can play around with this. So if we say, what if we just say 12 minus 6 divided by 2? And so here we do get 9. And so it does, so it does do this division and then subtract it. Oh yeah, so it does, I guess it is doing some order of operations for us. What if we then did squared? And what is that? 6 divided by 4, 20. Yeah, okay. So Python is doing some order of operations for us, which is actually something that I learned today. I will say I would not recommend depending on that. And I would just, if you want things to happen in a certain order, just put parentheses around them. But yeah, fun. Python does have a notion of order of operations, unless it's actually just going right to left. This is something that actually I hadn't thought about recently. And okay, what if we instead said 6 divided by 2 minus 12? And okay, yeah, it is actually doing some order of operations for us, which is super fun. But yeah, great question. Cool. Okay, so strings. So you can use double quotes or single quotes. At Google, we use single quotes. In general, you should just be consistent. So we have a variable called my name, and then we could do something like greeting equals, and I could say hello, and then plus my name, and then plus an exclamation point. And if I print out greeting, we will see something that is wonderfully instructive. And you will notice that it does not give us a space for free. And this is like a very common early gotcha, that if you want spaces in between your words, you have to add them yourself. So you can add a space there, and if we rerun this, hopefully that's looking a little bit better. But so the plus sign, if you have two strings, we'll just say stick these things together. Our fancy Python word for that is concatenation. But you can just say adding the strings together and like, it's fine, right? But if you want to be exact, we're concatenating them. So you can use this where you just kind of add some things together into a new string. But often in Python, if we want to sort of print out some information inside of a string, we'll use what's called a format string. So here's another example. So this is my favorite coffee drink is a cortado. Longtime Global Hack Week fans will know that I am a caffeine addict and love coffee. And sadly, we're not actually going to do the espresso event, Hack Your Espresso event this time. But we will still talk about coffee here. So my favorite drink is a cortado, which is just a small sort of espresso and milk beverage. And if I want to come up with a fun fact about myself, I could type something like this. I could say fun fact equals, and then I'll just type a letter F and then some quotes. And I can type out a string, and I can say my favorite coffee drink is a, and then I'll type drink name. And then I will say it's the best. Now, one thing you'll notice is that before this quote, I put a backslash, which just tells Python the string is not ending here. This is common in a lot of languages. If you are using single quotes to create your string and you want a single quote in the middle, you can just do a backslash to say, hey, this is not an end of the string quote. So we use our variable name right here. And what we can do is put these curly braces around it. And because we started our string off with an F, this is telling Python, hey, if I have this curly brace pattern, look for this variable and put it in there. So we'll just print out our fun fact here. It says, my favorite coffee drink is a cortado. It's the best. So hopefully this looks like what you expected it to look like. And the nice thing is that if, say, I'm going through a phase and I'm really into cold brew, I could change it to cold brew, and if we run it again, it says my favorite coffee drink is a cold brew. It's the best. So that is a format string, and they are very useful. A couple other minor things that we won't use a ton in this session because we're doing sort of image-based machine learning, but it's still fun, is that we can get the length of strings. So we can say, oh, the places you'll go as a variable name and set it equal to congratulations. Today is your day. You're off to great places. You're off and away. I actually do know like kind of the majority of other places you'll go, which if we need to kill time later while we're waiting for our model to train, I might recite for you. Oh, and I misspelled congratulations. Great. So we have a very long string here, and we can print out the string, of course, and we can just put it there. But if we want to see how many letters are in this string, we can just say len, which is a shortened version of length, and an opening parentheses and a closing parens, and we can run that, and it'll say 84. So there are 84 letters in that little string that I typed out. So that's very useful for just getting a sense of how big is or how long is your piece of text. And that's just how many characters are in there. You can also do what's called accessing inside a string. And so we can say, oh, the places you'll go. And if I want to get a specific character, I can use the square brackets and type in an integer. So let's say I type in 5. Now, if you run this, we'll see it gives us the letter A. And if you look closely and you count out, okay, 1, 2, 3, 4, 5, the 5th letter is actually R, and A is actually the 6th letter. And so if you have programmed a lot, you probably know this is because in a lot of programming languages, you start counting at 0. So really what it's doing is it says 0, 1, 0, come on, 0, 1, 2, 3, 4, 5. And so our number 5 index is in fact A. That is something that you'll see again and again, is that when you are sort of indexing where something is in a list, you will start counting at 0. So your first thing will be thing 0. And so if we replace that with a 0, we'd see, oh, okay, that gives us the first letter C. Awesome. So we've covered arithmetic with numbers and doing some fun stuff with strings. We did adding strings together or concatenating them. We did format strings, and we did getting the length of a string. Let me know how we're feeling. Like, I'm actually curious to hear in the chat. Maybe let's do like a 1, 2, 3 scale. Actually, because we just talked about indexing from 0. We'll do 0, 1, and 2. So let's say 0 is, whoa, this is a lot, and it's way too fast. 1 is, hey, this is feeling good, I'm learning some new stuff. And 2 is like, wow, I already knew all of this. Like, please be more interesting, Will. Or just let me know how it's going. Oh, RPJ, so good to know. I'm glad that this is working for you. But yeah, give me a little, let's say 0 is too fast, and 1 is right on, and 2 is too slow. Great. Ganit, good to hear, good to see, good to read the chat. Awesome. I'm so glad this is feeling okay to folks. Neutron said 2 out of 2. Cool. Fair enough. All right. Well, we will keep heading on. Oh, Ahilu. I don't know. Ahilu. I'm so actually psyched to hear this is your first time learning Python and that it is going all right for you. Absolutely love that. Okay, so it sounds like most folks this is okay. A lot of folks this is review, and that is honestly quite all right. Thanks for hanging out with us. If you have any questions, of course, keep that chat popping. Otherwise, we'll charge ahead and we'll look at some Booleans. In fact, actually, just to demo another fun thing in Colab, you can actually do some fun text little blobs. So we could say Booleans. We want to learn about Booleans, and it gives us a nice little header there. You can do that just with the plus text up here. All right, so Booleans, these are true or false, and we usually think about a statement being true or false, right? So for example, we could say the statement, sunny in Seattle, and that is of course false right now because it's like evening, and I want coffee, and right now that is true, because I always want coffee, right? It's delicious. So we learned before, yeah, we can just print these out and they work, right? But we can also use them in logical statements together. So something I want to show is we can use the and operator. So for example, I could say sunny in Seattle and I want coffee. And that is false. Because it's basically saying, are both of these things true? And one of them is true, but they're not both true. So the and of them is false. You can also guess what's next. We can, instead of saying and, we can say or, which just says, are either of these things true? And this, of course, is true because I want coffee is true. Another fun one that we can use is the not operator, which just flips if something is true or false. So I could say not sunny in Seattle. And that's actually true, right? So it is true that it is not sunny in Seattle is one way you can think about reading it. And we didn't talk too much about why Python, which I don't know if anybody has questions. I love talking about Python. But one of the things that's really nice about Python compared to some languages, especially older languages like C++ and Java, is that just a lot of times Python kind of reads like natural language, right? You can kind of read your code and hopefully pretty quickly get a sense of what you're trying to do here. So finally, we can add in something a little bit more complicated. So we could say, I want coffee and not sunny in Seattle. And this will be true, because what it first does is say, is it not sunny in Seattle, which is true. And then it says, is I want coffee and not sunny in Seattle both true? And both of those are true. And so the resulting expression value is true. So there's some fun with Booleans. Now I want to throw out a little challenge, and I want you to try to do the challenge in Colab, just so you can like get some practice actually typing out some Python. So I want you to try to create a variable called my age that holds your age, and another one called my name, which contains your name. And then I want you to create and print a string that says my name is, for me, it would say my name is Will, and my age is 25 years old. Oh wait, no, this is from a while ago. 27. I'm 27 years old. Wow, blast from the future. I don't know. But I have a little text blob here. In fact, we'll use the text again. Say challenge. And I'm going to update this because your boy is getting old. And so do that challenge down here. And I will give you just a quick second to do that, and we'll check back in. In fact, I might actually run and grab some more water because I am thirsty. Also, before I leave, another fun thing, if you put a little hashtag in front of a line, that makes it a comment, which basically tells Python, ignore this line. So if you want to leave a message for future readers, doing a little hashtag as a comment is a really good way of sort of letting a future human know what you were thinking at that time. So I'm going to run and grab some water, and I will be back, and we'll see what we wrote. All right? Have fun. Okay, I'm back. I did run, I will admit. I guess there are different ways we could do this. Hopefully everybody has their code written. Somebody asked how to access that doc. Yes, so Neutron, if you are trying to code along with us, you can go to collab.research.google.com, which I'll drop in here, and you can just come down here and click New Notebook. It'll give you a new one. You are also welcome to follow along in real time with what I'm doing. And let's see. Yeah, restricted. Oh, wait, no. We'll say anyone with the link can view. Perfect. Hello, hello. Yeah, so if you want to sort of watch what I'm doing live, and you can even copy my code and paste it into your own Colab if that is helpful. That is an option for you. Okay, so hopefully this challenge was not too hard. So first we'll say my age, which of course we litigated is 27, and then my name, and we'll say will. And this will, of course, be your age and your name. Notice that here, this is an integer, and here we have a string. So now we'll create a new string, and we'll say, I don't know, we'll call this introduction. And we can use a format string. So we have a little f and some more quotes. And we can say, my name is, and we'll use curly brackets and put my name in the middle. And then say, and my age is, and then do the same thing for my age. And so now, if we see what's inside there, we'll type, my name is Will and my age is 27. Let me know if you have any questions about that. Hopefully everybody got that little challenge. Cool, so we will continue ahead. We're 40 minutes in, and it seems like things are going, things are feeling good. But let me know if, again, if I'm talking too fast or if you have any questions. Yo, Shivansh. Hello. Okay, so now we're going to get into some more complicated stuff. Let's say some more complex stuff. We're gonna level up our Python, and we're going to do this with collections. So the first collection we're going to talk about is a list, and so we can do. I actually kind of like doing a little text. We'll say lists. So far, all of our variables have been single things, right? They've been like one word, one piece of text, or one number, or one true or false. But one of the cool things that computers let us do is work with lots of data at once, right? And in order to do machine learning, which we'll talk about later more, you have to have actually a ton of data. And so you don't want to have to declare a variable for every single thing you want your computer to remember. And so this is where lists come in. So I'm going to declare a list. Just like we declared variables in the past, I'll come up with a name called cities and then an equals sign. And then I'm going to do two square brackets. So inside these square brackets, I can put any data that I want, and it'll be inside our list. So our list of cities, we'll put Nashville. And then after this, outside of the quote, we'll put a comma, and we'll say Boston. So these are the two cities that I grew up in, and they're both elements in our list. And so if we just print out our list down here, we see Nashville and Boston. It remembers two things at once. But if we want to add something new, so 3 years ago I moved to Seattle, we can say cities.append, and we can add a new value called Seattle. And so now you see Seattle gets added at the very end, and our list is one element longer. And that is how we add stuff to lists. So we created a list in the first line, and then we appended another value to the end, and then we just saw what was inside it. Now, just like with strings, if we want to access a particular thing in our list, we can do it with square brackets. So 0 will give us the first thing in our list, and 2 will give us the third thing in our list, right? Because we start counting at 0. And so we see this is exactly what we expect. Nashville is the 0 index, and Seattle is the 2 index. Do we have any questions about lists? Is this feeling okay? We will get a little bit deeper into how to do things with lists in a second. Also, actually, this is a good moment for me to drop. You only get this because you have hung out with me for 40-ish minutes. But to drop the little feedback form. So if you have any feedback for me in terms of how things are going, or changes you'd like to see, or or any advice, let me know in this feedback form. You can also, I guess actually I will just pull it up for just a second. Hopefully it actually works for everybody. So you can let me know, was this way too slow, just about right, a little bit fast, or way too fast? You can also, right now, this is the only session where you can submit new recommendations for whatever I get tattooed on my arm. It's a temporary tattoo, of course. But yeah, up to 16 letters of some kind of phrase. If it was like really, really good, maybe it could be a few letters longer, but try to limit it to 16 letters. And then anything else you want to let me know, how things are going, if things are, are working out for you, or if you have any questions. That is always a good thing to put in there. So I will go through and look at all of these at the end of the session. And I'll repost that link later as well. Okay, so it sounds like folks are good with lists. One great question, Killer Looks. What's the difference between an array and a list? So this is a really, really great question. And it gets a little bit nerdy. So in most programming languages, an array is really just a chunk in memory, right? So like your computer has a bunch of memory and your Python program gets some of that. And so an array is literally just, this is this chunk of memory, right? And the way that arrays work is that each chunk has to kind of be the same size, right? So like integers are all the same size. And so you can put, a piece of an integer in the first place, an integer in the second place, but it's a continuous block of memory, right? What gets a little bit tricky is when you have things that are not all the same shape or size, right? So in most programming languages, actually including Python, if you use strictly an array, everything has to be the same data type. In Python, you actually can do things where you could say, blue and 42, and that is actually a valid list. And that is because lists are a little bit more abstract. So the short version is they're pretty similar, right? They all store like kind of a bunch of stuff in a list or sort of in a collection. But lists kind of give you more flexibility. They do a lot of things like automatically getting bigger or smaller as you change their size. And they can also support lots of different data types in the same list. There are a few other details. But I would say mostly you can think of them as doing a similar thing. They're all store data kind of in a line. But an array usually, depending on the programming language, is a little bit closer to the hardware, and it's just literally a chunk of memory. Whereas a list is Python has created this object that's pretty flexible and can hold all kinds of different things. Hopefully that gives you some context on if you're coming from like for example, if you're coming from C++. A vector is kind of an abstraction over an array. If you're coming, I know Java has arrays. If you are, I actually need to refresh on this, but like a JavaScript sense of a, I think they actually are referred to as arrays in Java or in JavaScript. But JavaScript's notion of that is actually really similar to Python's, where you can store lots of different stuff in it. But yeah, don't want to get too in the weeds. But hopefully that Killer Looks gives you a little bit of sense of the difference of an array and a list. But usually we treat them kind of the same. Awesome. So that was lists. Hopefully my explanation did not confuse anyone more. But now we are going to, if I can find the old screen of notes that I had. Come on. I will admit I do have notes that there we go. Notes that I'm not coming up with all this kind of off the dome. Okay, so lists are really great because they just let us store a bunch of stuff in, for lack of a better word, in a list. But sometimes we have data that doesn't really fit a list. Sometimes we have data that is kind of key value pairs. So for example, I could ask all of us our name and our age, which we did earlier, right? And in that case, we might think of, okay, you could have a list of all of our ages and a list of all of our names. But really those pieces of data are connected, right? For every age, there is a name. And for every name, there is an age. And whenever you have that kind of thing where two types of data are really connected, you might want to use what's called a dictionary. So my example here will be city populations. So we can say city populations is our variable name. We use an equal sign, and then we'll use those curly braces. So I'm going to type this out, and we can unpack it in a second. But I will say Nashville, in quotes, and then we'll have a colon, and I'll put 692,000, which is roughly the population of Knoxville last time I checked, and then a comma, and then quotes, and I'll say Boston, and a colon, and I'll say 684,000, Actually, what if we did it live? Population of Nashville, probably low because this is a while ago. Oh no, yeah, that's basically. Oh, it's okay, 2018. So that is probably a little out of date. 2022. Oh wow, 1.2 million. Okay, we'll update it. We'll say 1200. So 1.2 million. What is the population of Boston? Wow, this is okay. I don't want to get sidetracked, but there's this subtle difference between a city and what we call a metropolitan area, right? And the city is like, oh, what's literally the city limits, right? Where the city itself sort of picks up your trash, and then what's like all the people that live around there. And so the current metropolitan statistical area of Boston has 4.3 million people. But you come down to here, the actual city, it says has 687,000. So we'll use that number. In fact, actually, I am getting sidetracked here, and I apologize. But now, what if I say specifically Nashville City? Okay, here it says 707, and that seems like a reasonable number. Okay, I digress. So we've created a dictionary. And in this case, a dictionary is really just a collection of key value pairs. So here's our first pair, and our key is Nashville, and our value is 707,000. So we have our key, and then a colon, and then our value, and then a comma before our next thing. So then our next line has another key value pair. We have Boston, and then a colon, and then number 687,000. And fun fact, in Python, you can put a comma at the end, which I really like doing, because then if you want to add something else later, you can just copy this line and paste it and do some stuff. Whereas if you do that and you add something later, you might forget that you need to add a comma. So fun fact, you can put a comma at the end in Python. So if we just print out city populations down here, cool. As you expect, we get our data. Nashville is 707,000. Boston is 687,000. So if we want to get a specific value, we can use our city populations dictionary, and we can use our square brackets. But unlike before, for strings and for lists, we just put a number. But for dictionaries, we can just put the actual key that we want the value for. So one of our keys is Nashville. And so if we do square brackets and we put Nashville in the middle, we'll get the value for that key. So this is a really, really nice way to store data that kind of comes in pairs. You can think of this kind of like a dictionary, where you have a word and you want to look up its definition, right? And so in this case, instead of a word and a definition, we have a city and its population. So now if we want to add a key value pair, we can stick with this theme and add Seattle. We can look up population of Seattle 2022. And okay, again, it's giving us the metropolitan statistical area, which is just messy. Okay, the largest city, Seattle, 762,000. So we'll do that. So the way we can add something new, we can say city populations, add our square brackets, and we can actually put in a key that doesn't exist yet. So we can say Seattle, and then use that assignment operator, the equal sign, and put in the value we want to put in that spot. So basically, you just kind of act like it already exists and say, this key should now have this value. And then if we get out city population, you can see that Seattle is now in our dictionary. Oh, I am so glad that this is helping you learn, Katan. I really appreciate hearing that. Okay, one final thing that we'll throw out there is that you can type city populations or the name of any dictionary, and you can say .keys, and then put two little parentheses at the end. And this will give you basically a list of all of your keys in your dictionary. You can see that it actually says key dicts here, so it's not technically a list, but it usually will function like a list in most cases. So for example, if we said, get us the last thing, oh, okay, this is great. This is a great example. So it doesn't actually support indexing because it's not technically a list. It's technically this weird key dictionaries thing. So if we want to treat it like a list, we can actually wrap this in what's called a list constructor. So we just type the word list, and we have our parentheses around that in the middle. And so now this actually turns this sort of kind of list of keys into an actual list. And so now we can say, give us the 2 index, and it gives us Seattle. Another just fun detail is that you can also do this with values. And great, we get the second thing in our dictionary. Okay, this is, I'm going to give a warning that we're going to get a little bit nerdy for a second. And if you're just kind of hanging on for dear life, don't worry about what I'm about to say next. But one distinction between lists and dictionaries historically has been that lists are always ordered. So the thing that you put at the front of the list will always be at the front of the list. The thing you put at the back of the list will always be at the back of the list. And historically, dictionaries have been what we call unordered, because basically you only access things from the key, and you don't actually need all of your things to be in order in a dictionary. And this historically has been true. But in Python, I think it was Python 3.9, so kind of a newer version of Python, it became official that actually, by default, dictionaries will add things that you add to them at the end. So we see actually in this case, Seattle's at the end. So the little nerd blurb here is that oftentimes people will talk about dictionaries as being unordered. And this used to be true. Technically, it is not true anymore, but usually you still treat your dictionary like it is unordered. That's my little nerd blurb, and that is dictionaries. Okay, so I want to try another challenge for a second. We will say, boom, text, challenge. And we will say, I'll actually just copy over this challenge. So I want you to create a dictionary that maps the name of you and a couple of family members or friends to their ages, and then give yourself a birthday by adding 1 to your age, and display that that resulting dictionary. And we'll say, do your challenge here. And of course, hit me with any questions you might have. So we said, so basically our dictionary is equal to JavaScript objects. Yes, this is a really good comparison. So people will at me and say, oh, they're technically implemented differently. But really for all purposes we care about, they're basically the same thing. In fact, there is a really nice Python library that will turn your Python dictionary into a JavaScript object and spit it out to a JSON file. So yeah, dictionary is basically JavaScript objects. Okay. This is maybe requires a little more typing, so I'll give another minute. And then we'll charge ahead. Okay, so if we want to create a dictionary, we can start by declaring our dictionary name. So we could say, family. We could say family ages. Or we could just call it ages, because we might be friends and family. Then we'll do our curly braces. And so now we can start putting key value pairs inside here. So I'll start with myself, and I'll say 27. And then I will throw in, let's say, my brother John, and he is 20. He just turned 29, actually. And then why don't I put in my sister Julia, and she is. Oh, you ever have that moment where you're like, wait, how old is my sister? I'm pretty sure she's 25. Yeah, because her birthday is on Earth Day. Okay, cool. We're feeling good about that. And so we have Will and John and Julia. I first put equal signs, but we of course use colons in a dictionary, and that is why I was getting those really helpful little squigglies. Good catch, Fleabag. Awesome. So we have our ages. We can print that out. That looks good. And then in our challenge, we say, give yourself a birthday. So we can say ages, and then we can say will, and we can use that plus equals operator from before and just say add 1 to whatever value is inside will. And we print that out, we can see, oh, okay, will becomes 28. And so that is our sort of solution to our challenge, creating a dictionary with some ages and giving ourselves a birthday. So let me know if you had any problems with that or any questions about how that works. But hopefully that all felt pretty good. Sweet. Okay, so now we're going to move into our sort of next big section. And I do so love adding some little markings here. So we will say ifs and loops are the big things we're going to look at now. Okay, so if statements just let us check some condition and execute code only if that condition is true. So for example, I could say pineapple belongs on pizza. And that is, of course, true, because pineapple on pizza is delicious. And if anybody wants to fight me, get at it in the comments. So what I can do now is I can say, if I want to execute some code, only if this is true, I can say just the word if, and then I can type out my Boolean value, if pineapple belongs on pizza. And then this is called a print statement, which is just a way of another way of printing out the value of something. We've just been typing whatever we wanted at the bottom of our cell. But if you do it inside your code, you can do it like this. So we can say print, I like pineapple on pizza, and I don't care who knows. No, who knows? And if I run this, of course, it prints it out because this statement is true. Ooh, somebody asked, what if we wanted to add 1 to all of the keys? And this is a great question and something that we will look at in a second, because we don't have the tools to do it yet, but we'll learn how to do something like that in just a moment. So this is our basic if statement. We only run this code if this thing is true. And of course, pineapple belongs on pizza, so it is true. But if in an alternate universe, pineapple on pizza was bad, and we said this is false, then nothing prints out. And so it just skips over all that code in our if statement. Hopefully this makes sense. Sticking on the food trends, we'll explore something called an if-else statement. So I'll give myself another Boolean called mashed potatoes are good. And this is false. I don't like mashed potatoes. I think they literally are baby food. And so not, therefore, me, because I am not a baby. But we can use this Boolean. And so we can say if mashed potatoes are good. You know, just like before, we could say, I like mashed potatoes. But if this thing isn't true, we can say else, and we can say mashed potatoes are literally baby food. And so if we run this, we'll, of course, print out the else statement, mashed potatoes are literally baby food. But of course, we flip this around, it would print out the original statement under the if, and would say, I like mashed potatoes. Yeah, we will look at loops in a minute, but we haven't covered loops yet, so don't want to invoke that. Okay, cool. So hopefully this if-else construction kind of makes sense. Let me know if you have any questions. This should be pretty similar to other programming languages, but one key here is that we have, instead of in other languages, you might use curly braces, and in Python, you just use indentation. So basically, it's the 2 spaces here that tell Python that this line of code belongs to this if statement. And so similar to here, this print statement belongs to this if statement, and this second print statement belongs to the else. And so this is how Python knows what code to run and what code to skip over. So for example, I could add another print statement that just says, yo. And in this case, it prints out both. So it does all of this code if this if statement sort of executes. So hopefully if statements and else statements kind of feel good. We can also, instead of just using a Boolean value, we can do comparisons. And we haven't looked at comparisons before. Ooh, okay, really great question. Somebody asked 2 spaces or 4 spaces. And this is also a style choice. So just like the single quotes and double quotes, both of them work. You can, if you want to, you can do 4 spaces. So like that, right? And this is legal. Again, in Python, we just say be consistent if you're using 2 spaces or 4 spaces, and you can do this. And there is nothing wrong with this. In fact, a lot of people think this is a little bit more readable. The one thing that I will say is when you start writing like really complex code that gets kind of really in-depth, sometimes you will have nested statements. And so this is just a silly example that will don't worry about like how this actually works. But we might say, we might define a function and that indents us. And then we might say, if true, or if bool val, then we could do something else. We could do a for loop for x in range 3, and then we could say, another if x is equal to 2, and then we can print something, right? We can print x. Just a bunch of random things. And this, to me, this looks okay. But if we do 4 spaces for all of these, there we go. Suddenly, to me, this just becomes a little bit too stretched out. And if you have like not a super wide screen, it can be kind of hard to read it all. So definitely pick whatever you want. Just know that kind of further down the line, you might prefer 2 spaces just because it makes your code a little bit more compact. But some people think 4 spaces is just easier to read. Somebody's asking if I can teach game development. I will admit, it's something that I have always been interested in. I just have never really done much game development. So at this point, I wouldn't be a great teacher. But I promise that if I ever get into game development, I'll do some of that at Global Hack Week, maybe next year. But I appreciate the compliment. It's very kind of you. Okay, so that's 2 spaces versus 4 spaces on the indentation. Okay, so I mentioned we can do comparisons as well, right? So let's create a variable called my age. We'll set that to 27, but you can set it to your age, of course. I will say if my age, and I'll say greater than 16. Then I'll do another colon, which just tells me, we're in our statement, and I can say print you cannot get you can get a driver's license in the US. And I'll just print that out. And hey, it says I can get a driver's license in the US. Another one we could do, if my age equals 22, we could print I don't know about you, but I'm feeling 22. Taylor Swift stands in the house. What's up? And we can run that, and that won't print out because we're not exactly equal to 22. So hopefully this one seems pretty easy. My age is greater than 16, and so that executes. In this case, we don't use a single equal sign to check for are these things equal, because remember, we already used the single equal sign to assign something, right? This is basically saying put 27 into the variable my age, whereas here we're saying are these 2 things the same? And so we just use the double equal sign for that, and that will print out. So if we change this to 22, both of them print out. I don't know about you, but I'm feeling 22. And then if we brought it down to something like 10, then nothing prints out because neither of those comparisons are correct. Okay, so hopefully this is feeling good. We're going to dive in and do something just a little bit more complicated where we mix some of the things that we've learned together and create kind of a more complex statement. So let's say we have a variable that is the temperature in Fahrenheit. Let's say that's 82, and we have some weather, and let's say that right now that is sunny. So we might have gotten this from a like a weather app somewhere. Somebody asked, it's basic Python till now, and the answer is yes. This whole session, we're just kind of doing some basic Python introduction and review, so we're ready to hit the ground running tomorrow. or not tomorrow, Monday. Yeah, so if you're already Python Pro, you're free to hang out with us, and I welcome you to do so. But if you already know some Python, then you can join us on Monday and wouldn't have to participate in this session. Awesome. So we have some weather data, the temperature and the weather, and so I'm going to say we're going to come up with basically an expression or write some code to tell us what kind of activity we can do based on the weather. So, for example, if I say if temperature in Fahrenheit is greater than 70 and weather is sunny, I'll do that colon there again. I'll print, let's go to the beach. Now, I'll use something called an else statement, which is kind of like a combination of an else and an if. So it's like if the first thing didn't happen, but some other condition is true. So if that wasn't true, but the temperature is less than 32 degrees Fahrenheit and weather is snowy, you can say print let's go skiing. Because if it's below 32, things are freezing, and we should be able to have a good time skiing. And then finally, we can type else. We can just say print let's stay inside, and we can do a little meh face. Okay, so just to review this, we have an if statement followed by an elif statement followed by an else. So if the temperature is greater than 70 and the weather is sunny, we're going to print out, let's go to the beach. If that's not true, but this statement is true, the temperature is less than 32 and the weather is snowy, then we'll print out, let's go skiing. And finally, if neither of those things are true, then we'll just print out, let's stay inside. So if I run this now, we'll get, let's go to the beach, because our original data says it was 82 degrees Fahrenheit and sunny, and that is like a good condition to go to the beach, right? However, if I change this to, let's say I change this to 10 degrees, it'll say, let's stay inside. Because if it was 10 degrees and sunny, it really wouldn't be a great time to go to the beach, but it probably wouldn't be a good time to go skiing either, right? Because, the sunniness, there might not be any snow. But if we change that sunny to snowy, we run this, now it says, let's go skiing, because it matches this second condition of being less than 32 degrees and the weather being snowy. So this is a little bit more intense, right? We're doing some comparisons, and we're doing some Boolean operators with the and we have an if, elif, else statement. So let me know if you have any questions about that. I'm also curious, again, to get our 0 being too, 0 is too fast. No, 0 is too. 0 is too fast. 1 is right on, and 2 is too slow. So let me know how you're doing. Drop a 0, 1, or 2 in the chat, or let me know if you have any questions. But otherwise, we will keep charging ahead. Okay, so somebody mentioned loops, and we're going to get into loops now. And loops are awesome, and they will help us do something that we talked about before. Oh, I'm glad to see we're getting a lot of 1s. We'll see if we have any 0s or 2s and maybe any questions, but I'm glad that this is kind of a comfortable pace for y'all. Okay, so to talk about loops, it's really hard to talk about loops without already talking about lists. And thankfully, we already talked about lists. Say loops. So I'm going to create a list of students. Let's see. I will grab some names recently from the chat. We have Amit. We have Misato and Yadav. And of course, if I'm butchering your name, please drop guidance on pronunciation in the chat. Don't want to do that to anybody. So we have our list of students. Now, if we want to do something for each of our students, then we can do what's called a for loop. And we do a for loop where we can say for student in students. And then we can do something. But I want to look at this for a second. So what this for loop is saying is pick the first student in our list of students and do something with this student in a variable called student. And then repeat that for every student. So this line of code, whatever we write here, will run for everything inside the list. So what if I wanted to welcome you all to the stream? I could say, we can use that format string again, and I could say, welcome to the stream. And then I could do student. So what this is going to do is it's going to run this line of code where each student in our list gets a turn being the student. So if we run this, we can see, welcome to the, oh, not the steam, the stream. Welcome to the stream, Amit. Welcome to the stream, Misato. Welcome to the stream, Yadav. And that is kind of our most basic loop. It just runs a line of code for everything in a list. We can also do like more interesting logic inside of our loop. So let's say we have a list of weather forecasts. And let's say it's going to be sunny, and then rainy, and then sunny again. Kind of unrealistic in Seattle. It would probably be 2 rainy days and 1 sunny day, but you know. And then let's create some variables that just count the number of days we've had. So we can say sunny day count, and we'll set that equal to 0, and we'll say rainy day count, set that equal to 0, and then we'll say snowy day count. And that will also get set to 0. So now we're going to do a for loop where we say for forecast in weather forecasts. And to start off, let's just print our forecast just so we can, make sure we know what's going on here. If we run this, we'll see we get in order all of our forecasts. We get sunny and then rainy and then sunny again. So hopefully this feels okay. We're just looping through all of our forecasts. But now we can actually do something based on that value. So I could say if the forecast is equal to sunny, then we could say sunny day count plus equals 1. And then I could say elif forecast equals rainy, and then another colon, and hit return, and I could say rainy day count plus equals 1. And then I could say elif again and say if the forecast is snowy, we can say snowy day count plus equals 1. Not snow day count, snowy day count. Boom. And then after this loop, we could say something like, we could say sunny day count and say sunny days. And we could do something similar for rainy days. And snowy days. So just to walk through what we're doing here, we loop through each one of our forecasts and we check, is the forecast sunny? If so, we add 1 to our sunny day count. Is the forecast rainy? We add 1 to our rainy day count. Otherwise, is the forecast snowy? And we add something to our snowy day count. And we can hit run. And just like that, we get our nice little statement where we say 2 sunny days, 1 rainy days, and 0 snowy days. Interestingly, you could add logic to fix this grammatically. So it says if it's 1, only say day, not days. But usually we don't worry about that. And we can see if we added, for example, if we added another sunny day and another rainy day, and we run this again, now it updates and it says 3 sunny days, 2 rainy days, and 0 snowy days. So you can really put however much logic you want inside of a for loop. So we can also use loops with dictionaries. And this is, I think, somebody raised a really great question about this before, is what if we wanted to do something for everything inside a dictionary? And we can do that pretty easily. So let's go back to our dictionary of ages. So say Will, and we'll put 27, and then we can put Richard, and we can put 24, Richard is my boyfriend, and then we can put Benjamin Franklin. And actually, let's see, how old would Benjamin Franklin be today? Okay, Google, do better. Just tell me how old he would be today. Okay, he was born 1706, and what is 2022?
I've always wanted to do this. How old do you think I am?
Okay, apologies for the thing, the word I can't say without it listening, chiming in. Okay, so allegedly.
Interesting. What makes you think that?
So allegedly, it's he'd be 316 years old. And okay, so we can print out ages, and that should be normal. Yeah, apologies for that drama. Oh, okay, right, 17 because of the way that dates work. But thank you for the catch. So we get our dictionary, but what if we want to give everybody a birthday? So if we just wanted to say everybody gets 1 added to their age. So what we could do is we could use a for loop, but instead of doing it over a list, we could do it over our dictionary. So we could say for key in ages. And the first thing I'll do here is just print out key, just so you can see that if you just loop through a dictionary normally without doing anything special, you just get the keys. And this is important to remember, is you don't get the key and a value, you just get the key if you're just iterating through a dictionary normally. So what we could do here is with our key, we could say ages, and then use our key just like we normally would to access something in a dictionary, and we can say add 1 to it. So everybody gets a birthday, and if we print this out again, you can see, sure enough, everybody levels up 1. And here we are, all a little bit older, a little bit more decrepit. Okay, awesome. So we're an hour and 20 minutes in. So honestly, props to everybody who has stuck it out. Hopefully this has felt good and nothing too crazy. I want to run through functions, and then I also want to take a look at using libraries, and then I think we'll be in a good place. So we are on the home stretch here. But I want to say, if you are here and you are listening to my voice, give yourself a pat in the back. Y'all have been killing it, and I really appreciate the engagement and all that jazz. Cool. So let's take a look at functions. And we'll add another little text box that says functions. Actually, we're going to call it functions because they're so much fun. I'm really funny. You can laugh now. Cool. So the thing that a function is basically a little package of code that we can reuse again and again. So sometimes you write some code and it's like really clever and you're like, wow, this is a great idea, and you want to use it somewhere else. And what you might do is you might just copy the code and paste it somewhere else. And this is fine. There's nothing wrong with this, except there are things wrong with it. And the biggest one is that if you've copied and pasted some code, then if you want to update that code, you have to update it. If you have to update that code, you have to update it in all the places that you copied it to. And so what functions let us do is package up that code so you can reuse it again and again without having to rewrite it. So we'll just look at writing a function. And let's say we want a function that just adds 2 things together. A kind of silly example for a function, but we'll do it anyway. So the way that we start a function is with the def keyword. And this stands for define, and it's basically just telling Python, I want to define a function. So we might say, define my adding function, and we'll do 2 little parentheses, and we will let it take some arguments. And arguments are basically things that you give to your function. So we'll say foo and bar, 2 just random names for some input variables. And so inside our function, again with that colon, we can say my sum is equal to foo plus bar. And now we can use the return keyword and return my sum. So if we want to then call this with some new numbers, we can say my adding function, and we could say 40 and 2. If we run this, we get 42. So I want to unpack this a little bit. One of my favorite analogies for functions is like the idea of a recipe in a cookbook. So a recipe basically tells you what steps you need to take to get some result. And usually the recipe will tell you need some ingredients, and then it will give you something back at the end, right? So like if you want to make a cake, it might say you need flour and sugar and eggs, and at the end you get a cake. And so that's kind of like what our function is doing. It says, hey, I need these ingredients, foo and bar, and at the end, you will get my sum. And you can keep reusing this recipe, which is kind of nice. So when we call it, we don't need to use the define keyword. We just say my adding function, and we pass in two things that become foo and bar. So it's kind of like saying this is my flour and this is my eggs in the recipe. Somebody asked what's on my head, and apparently you showed up late because I made a big deal of it. This is my flower crown. So longtime fans of Global Hack Week will know that the flower crown is a staple and the kalimba is a staple. And unfortunately, I have misplaced my kalimba, but I will find it before next time, and I will play some kalimba for you. But yes, it's a flower crown. Okay, cool. So that is a function, and we can make much more complex functions, and we probably will make more complex functions in the future. But the basic thing you need to know is that you're going to pass in some information, and you'll usually get something out. You don't actually have to pass anything in, and you don't have to return anything, but a lot of functions will take in something and give you back something else. So technically, when we used the print function before, this actually was a function, right? So you can pass in an argument like hello world, and it doesn't actually return anything, but it does go and print out something for you. So functions get a little bit more out there, but they're really, really useful, and we will be using them a lot. Cool. Do we have any questions about functions? Feeling good about functions? Nice. Okay, then we're really on the home stretch, and the last thing we'll look at is using libraries. So just like how functions allow us to reuse a lot of code that we've already written, we can also actually reuse code that other people have written. And this is really what libraries are. Boom. So if we want to use a library, we can use what's called an import statement that basically tells Python, hey, I want to use this code that somebody else already ran. So one example we can use is the random library. So we just type import and the library we want to import. And in this case, I'll type random. So what random does, as you might have guessed, is gives us random stuff. So we could say random.random and then do two little parentheses. And this will just give us a random number between 0 and 1. Now, a couple things to unpack here. So first of all, we have our import statement, and this is the name of our library, which is random. And then in this case, we actually want to access the random function inside of the random library. I know it's a little bit confusing because they're both the same name, but the library name is random, and there's also a function inside it called random. And we just put a little dot in between there to tell Python, I'm looking for the random function inside the random library. And then we put these two little parentheses on the end because it's a function, and that's just how you call a function. And it gives us back a very fun random number. And you can rerun this, and you can see that we do, in fact, get another random number. Let's see. Somebody said, can we use passarg in functions like we do in loops? Let's see. Are you talking about passing in an argument like a list or like a collection into your function? Or are you talking about using like the pass keyword in order to actually, yeah. If you clarify my question, we can pass in arguments inside functions. And in loops, you can kind of think of the thing you're looping in kind of as an argument to your loop. Oh yes, yeah, you can use the pass keyword. So this is actually a fun little detail because somebody asked, I'll throw it in here. So jumping back from libraries, say you write your loop. So, we have my list and we have some things, and you say for num in my list, but you're not ready to write anything yet. And if you just go on and you do something else later, so let's say later we say print hello, Python will actually complain about this because it's expecting something inside your loop. And so what you can do is you can just say pass, and this basically tells Python, don't worry about it, I'm going to get to it later, right? You can also do this in a function. So if you define your function but didn't actually have anything to put in it yet, you could, like back here, you could just say pass. And it says, hey, don't worry, I'm going to define my function. I'm actually going to fill out my function later. But yeah, great question. Let's see, somebody mentioned the random.rand range, which is another fun thing that you can do. So there are lots of different things inside random. You can also do rand int. So you can say random.rand int, which will give you a random number in a random integer in between two integers. So let's say, between 1 and 10. And notably, I believe this will include the starting number, but never include the ending number. The tooltip might actually be helpful here. Including both endpoints. So it will include 1 and 10 in your range. But yeah, there are a million little useful things inside the random library, which actually, we can look at this. If you wanted to know, okay, somebody asked, can we get random chars? And I like, this is a good question. Can you get random chars? And the answer is yes, but you have to do a little bit of extra work. So something that we'll often do is we can create basically a string with all the letters of the alphabet. So I can say alphabet, and we can just say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. There are like libraries you can import that will just like give you the alphabet, but this seems easy enough for me, right? So we have the alphabet, and what we can do is we can say random.choice, and this will give us a random selection from any kind of collection. And technically, a list is a collection. Or sorry, technically, a string is a collection. You could also technically turn it into a list if you wanted to, but you don't have to. So now we're basically using the random library just to say, get me a random letter from the library. And okay, here it's U. If we run it again, it gives us D. And that is a way to get a random letter if you want to. But good question. Yes, we can get from lists random things. Yeah, awesome. I'm glad that makes sense. Okay, so you can import things from random. So there's a question of, oh, wait, how many different things are there inside this library? And one really useful thing you can use is the dir function. So dir, I believe it stands for, actually, I'm actually not sure if it stands for directory. Usually it does. I'm actually kind of curious if it does in this case. But dir will basically show all of the things inside your library. I presume it stands for directory, but I'm actually going to, let's see. What does dir stand for in Python? Okay, it does say directory listings. I'm not crazy. Cool. So dir stands for directory. And if you pass in the library itself, it will just tell you just the names of everything in that library. And I would say use this carefully because it can be a little bit much sometimes. So you can scroll down and there is a lot of stuff in here. And you can see the things that we used before. You have choice, you get random bits, but we also have random and rand int and rand range. So that is a way of just seeing, hey, what's inside here. But if you want to actually have a description of what things are, you can always look up the documentation. So in this case, just what I would do is I would say Python random library documentation. And docs.python.org is great. And reading documentation can be a little bit scary, but it's actually a really nice thing to get good at. And so you can see, if you scroll down a little bit, you have basically a little entry on all the different functions. So if we scroll a little bit more, okay, rand range, and it'll show you how you can call them, and it will tell you what they return. So this is kind of nice. Somebody asked, is seed used for encryption? And so technically what seed does, well, okay, this is a good question, so we'll get into it. So you can use seeding for sort of like cybersecurity purposes and encryption to generate some kind of unique randomness. And I guess it does get used in that way. But basically what seed does is it gives your random number generator some kind of initial state. Right, random is technically pseudo-random. So let's say I say for blank in range, so this will just say do this 10 times, and I say print random.random. And okay, I get some random numbers, right? But if I say random.seed and I pass in 0, okay, I get different random numbers. And if I run this again, actually 10 is probably too big. Let's just say 4. Let's do four random numbers. Okay, so I get 4 random numbers. And if I do this again, I get different random numbers. But if I seed the random state as 0 again, I'll actually get the exact same numbers. And there are a couple of reasons for this. So by default, I think Python actually uses a bunch of stuff from your operating system, like the time to sort of generate the randomness. So you will be able to get something that usually feels pretty random. But specifically when we are testing machine learning algorithms, sometimes we want randomness, but we want the randomness to be consistent, right? Like maybe I want to randomly pick stuff from a list, but if I run that code again, I want it to randomly pick the same stuff. And so random.seed basically just tells you that the randomness that it generates will be the same starting at that point. This gets a little bit in there, but hopefully that makes sense. Seed basically just gives you a random number generator the starting point, and then after that it'll do its pseudo-random thing. But yeah, random number generation is actually like a really deep, like apparently coming up with a truly random number that is impossible to predict is like a really, really hard problem, and people work really hard on it. So yeah, you should know that Python random is a pseudo-random number generator. Cool. Somebody said, oh, you could random.seed, random.random. And you could do this. I think that cybersecurity professionals would say that doesn't actually make your randomness like in a technical sense any more random, but I do like it, and it is fun. Cool. All right, I think we're basically done. Okay, I'll show matplotlib, and then we'll call it a day. Okay, so one more library that we can use that's really helpful is called matplotlib. So we can say import matplotlib.pyplot as PLT. A couple of things to unpack here. So we say matplotlib, and then .pyplot is just saying that pyplot is something inside of matplotlib. So you can nest modules inside libraries. It's something you see a lot. And this final bit just says we want to call the thing that we're importing PLT. So this is just like an alias. And usually you don't want to alias your Python imports, but there are a few that are pretty standard. So we will often import pyplot as PLT just for kind of convenience. Okay, so what if I said we have 2 lists. We have X, and we'll just say 0, 1, 2, 3, 4, 5. And then we'll say X squared is 0, 1, 4, 9, 16, 25. So we have 2 different lists of numbers. And we can just say plt.plot, and this is a function that will accept 2 lists of numbers. So we can pass it in X and X squared. And then we can hit return, and it gives us this beautiful graph. Ooh, really great question from Lovely Bubbles XOXO. Why don't you want all of matplot? Okay, so yeah, this is actually a really great question, and the answer gets a little bit philosophical. But the answer is that usually the best practice is to only import specifically what you need. And one of the reasons for this is because you just don't need the other stuff. But 2 is you don't want 2 different things that are named the same thing. So for example, we could import, all of the stuff from random, but like, what if I later generate a random integer and want to create a variable name called randint? And in that case, because there's already a thing called randint that's defined, we have a lot of messy collisions because we've used the same name twice. And so I think the usual reason to only import specifically what you need is for namespacing purposes. It also just, like Cytronical Twitch said, it actually just takes time to import stuff. So when you import stuff, it actually is running that code. And in a lot of cases, it runs fast enough that it doesn't matter. But some cases, we do actually care. But yeah, really great question. And that's the answer that I would give. Okay, I think we are at the end of the line here. Y'all have done great. We have done a pretty basic intro to Python. We have covered data types and arithmetic and messing around with strings. We learned about if statements and else statements and how to do for loops over lists and dictionaries. And then finally, we took a look at functions and importing stuff from libraries. And so this gives us a pretty good foundation to jump ahead on Monday and learn about. We're going to be first looking at like what image data is and building a very rudimentary algorithm to try to predict things. And then in the future days, we'll really get into the heart of machine learning and use AI to look at a painting and predict what artist painted it. So it was a really great time to spend this Saturday night with you. And I'm really glad that you tuned in. So I will post that form one more time, and I will hang around for a little bit longer in case anybody has any additional questions. But that is really what I've got. So yeah, again, thank you so much for being here. I'll stick around just for a few seconds. If you have any questions, throw them in the chat. But otherwise, thank you for hanging out with me. It was great to have you here. All right. On that note, I'm gonna peace out and happy hacking, everyone. Happy Global Hack Week.